All right, second video. So in this video, I want to talk about power and fuses. So first with power. So in the circuit simulation, I made two circuits. They both have a battery that's 20.5 volts. There's a switch down at the bottom, and then there's a light bulb. The only difference is that one light bulb has a resistance of 10.5 ohms, and the other one has a resistance of 105 ohms, so about 10 times more resistance. So um, let's see about the bulb brightness. So I'm going to close both of these switches. And you'll notice, so the bulb brightness in this simulation is indicated by the length of these yellow lines. So the one on the left has a brighter bulb than the one on the right. So power is directly related to bulb brightness. We also know that power can be calculated. Power is equal to current times voltage. So now I'm just going to put ammeters in each of these circuits, and you could see that even though for both of these circuits the voltage drop across the bulbs is going to be 20.5 volts because that's how much is provided by the battery, but because the one on the right has more resistance, it's going to have less current according to Ohm's law. And because it has less current, and power is proportional to current times voltage, the one on the right has less power than the one on the left. So when we say that, that means that the battery is providing less power and the bulb is using less power. Therefore, the bulb is not as bright. And power, there were some questions about power from last week. Power is still work over time, and work is still the transfer of energy, except now we're talking about the transfer of energy from electrical potential energy into light energy and thermal energy. So that rate of change from one form to another is still power, but we're talking about two different forms that power, two different forms of energy transformation. First semester, we talked about mechanical energy. So power can be calculated with current times voltage. It's also equal to energy over time or work over time. So that is power. Then I also wanted to, if you scroll down on the left side, there were a few other things that we didn't get to in the lab. And one of those things is a fuse. So a fuse is something that regulates current. So fuses have settings for the maximum amount of current that they will allow to travel through them. So in this one, the way it's set, it's 4 amps. So no more than 4 amps can go through this fuse. So I'm just going to stick the fuse in here. And if I close the switch, since the current is 1.17 amps, which is well below 4 amps, this fuse allows the current to travel through and the circuit works. However, let's say that the battery provided more than 20.5 volts. So notice now as the current and the voltage go up, the brightness of that bulb goes up. It's getting bigger and bigger. And then when the current exceeds, it's about to exceed it now, when it exceeds 4 amps, watch the fuse. The fuse is going to, we say the fuse blows. So there. And inside, actually, if I get rid of this, you'll see that now the fuse is no longer, there's no longer a path for those electrons to flow. Even though this switch is closed, the current can no longer flow because this fuse is basically acting like an open switch. All right, so in this one, I just talked about power and fuses, maybe to help you with some problem solving that is going to come up. So in the third video, I'm just going to set up some circuits and have you go through some practice calculations. All right, so